Super fine.
The recording. So, hello everyone. Thank you for coming to this week's lecture on how to get funding and fellowships with Claire. She goes to the University of Chicago and she works in AMO physics. She is also one of the former SWIP presidents, one, two, four presidents ago. And I put the link to the recordings in the chat. So feel free to look at those in your spare time later.
Thanks, Jamie. Well, this should be a pretty chill talk, so feel free to interrupt me whenever. I'm hoping this will be kind of more like Q&A type things, but I'll just get it through the presentation. So how to get funding and fellowships. This is mainly geared for when you're a graduate student, particularly in physics, but it also applies to some of the other sciences. So let's go ahead and get started. So like Jamie said, my name is Claire, and I was the UIUC SWIP president for 2 years, 2015 to 2016 and 2016 to 2017. Maybe you recognize some of these people, or maybe not. I think Jamie was maybe at the tail end when I was a senior, and then I graduated. Yeah, so there's Rachel and Cassie, Rithi, Hannah, Andrew, and Savannah, and Cami is like in the dark on this laptop screen right here. And like Jamie also said, I'm a fourth year grad student at the University of Chicago studying atomic, molecular, and optical physics, and I'm in the Simon lab. So this is a picture of one of our experiments, and it has our beautiful blue laser, and it's used to excite a cloud of rubidium atoms in a vacuum chamber. So lots of cool stuff there. That's like a whole other talk I could talk to you about. But yeah, so my street cred is that I won the NSF GRFP, which is a fellowship, in 2018. I applied in 2017 when I was a senior and I lost. So I got kind of like both sides of the coin there. I've also edited a number of fellowship applications by now. So if you guys want to like send me your applications for feedback, and it's like super hard during a pandemic too to like get feedback sessions going. Yeah, feel free to just send me your application. Um, so I don't know if you guys really know about the grad school process, but it was kind of a mystery to me for a really long time. Kind of until I was a senior, honestly. So I'm just hoping to demystify it on this slide. So this is kind of like what I imagine in my head as a cookie cutter graduate school experience, but in physics, but it varies a little bit based on what school you decide to go to. So in general, the whole PhD process is going to take about 5 to 7 years. So I have this like, a little chunk of 5 to 7 years here. And the first 2 years are going to be kind of like undergrad part two. You'll be taking a lot of classes where your first year might be like your introductory classes like quantum mechanics and stat mech, regular classical mechanics, and cred. The last one, the last one that you do usually in an intro class. And then after which you'll probably get something called candidacy. So you've like achieved candidacy. This is sometimes after a qualification exam. And you'll take more classes called elective classes, which will fulfill your basically general requirements to be a grad student. And you can kind of pick and choose what these are. At least at University of Chicago, these classes don't usually have exams and are all homework based. So it's like really, really chill. So after those 2 years, the remaining of your part of your grad school is all going to be research. This is going to be like your full-time job in a lab or a theoretical group with a advisor. And so there are some distinct events along the way. I mentioned the qualifying exam. U Chicago doesn't have one, which makes it really, really chill. You just need to complete your classes, but a lot of grad schools still have this exam, after which you will most likely achieve your master's degree. So this is where you could potentially say, hey, maybe a PhD isn't for me, and like you can leave with a master's, or you just keep on going to the PhD and just end up picking a master's up along the way. So after, if you choose to keep going with your PhD, at some point during your research time, you'll form what's called a thesis committee, which is maybe like 4 or 5 people who are professors who will be kind of like your guiding mentors along the way in your research, and you'll meet with them like on a year-to-year basis so they can check in and see that you're doing all right. Then kind of at the end of your PhD experience, you'll write your thesis, and then you'll defend your thesis, which is basically a 1 or 2 hour presentation where you overview all the research you did as a grad student, and they give you your PhD. And then you get to figure out real life after that. But that's a future you decision. But the whole thing I'm going to be talking about today is fellowships and funding. And at least in the sciences, in particular physics, you should be getting paid this whole time. You should be getting your tuition covered. You should be getting health insurance. But it's really kind of unclear, where does this money come from? So let's talk about that. That's you. This is you. So this is you as a grad student. In grad school, there are kind of 3 main sources of funding. There is your grad school physics department, or science department in general. There's your research advisor, and then there's a government agency, organization, or individual, and they each kind of have their own pools of money that you can get. When you first enter grad school, you'll probably most likely have either a teaching assistantship, which is a TA, or a research assistantship, which is an RA. And so, for example, if you have an RA, this probably means you've found an advisor and you'll be doing research with them, and they are the people who are funding you. If you don't yet have a advisor or somebody who can at least support you financially, because you might be working in a lab, but you might not be able to get funding from them because they can't afford you, then you'll end up teaching and you'll get funded as a TA. So there are the remaining 2 options. And these are like the pretty sweet areas of funding, which are, you could be getting scholarships or awards from your department, even fellowships, which will basically be your full stipend, scholarships from an external source, and fellowships from an external source. And just for reference, little arrows are kind of like small amounts of money, 1,000 to 5,000 typically. And big arrows are going to be about $30,000 per year. This is going to be your stipend. You can basically rely on ballpark 30K per year as your stipend as a grad student. And an important thing about this is that you're really only allowed 1 big arrow at any given time. So for example, if you get a fellowship from the outside individual, then your research advisor won't be paying for you, you'll be paying for yourself. So unfortunately, you don't get double money. You don't get like $60,000, you'll still get about that like $30,000 ballpark range. Yeah, does anyone have any questions at this point?
I have a question. Could you get like a fellowship from a government agency and a teaching assistantship?
Potentially, kind of. So what would probably end up happening there is you would be funded by the government agency, and you'd still be under a teaching assistantship or TA, but you wouldn't be getting paid through the TA. It would be like you're supporting yourself, but you actively want to teach. So like you're choosing to teach, but you're not going to be getting another like 30K from that. You might get like a little bit of side money, because like you are doing work for your department, and you can honestly probably argue for that. So instead of 30K per year, maybe it's like 35K per year. So I'd say, yeah, go ahead and try to get money where you can, because you deserve it. There's also kind of a subtlety between what a fellowship is and a scholarship. So fellowship is kind of based on your merit, whereas scholarship is like includes more options like financial need, and kind of like something you apply for, and crap, what's the word? It's a little bit different. It's smaller amount in value. scholarships for grad students are less common, but they still exist out in the world, and you can try to apply for them. All right, any other questions? Cool beans. All right, so we're gonna zoom in on each of these big chunky arrows a little bit more. So from your research advisor, you could get this research assistantship or RA. And the expectation when you have an RA is that you're just gonna be doing research essentially full time. Maybe you'll be taking 1 or 2 classes during this time, but research is your top priority. And how do you get this? You talk to your advisor. So it's kind of a matter of like, hey, so and so, do you have funding for me to be in your lab this quarter or semester or whatever? And they might not. So I have this note here that says not all professors may have the money to support you, in which case you'll need another source of funding. So a lot of people, when they first become grad students, they're not like quite fully in a lab yet. So your advisor doesn't necessarily support you fully, in which case you kind of work in a lab, but your main funding comes from a teaching assistantship, or TA. So this is where you, you guys must have had TAs by now who are grad students. This will be you. So you're going to be running discussion sections or labs and grading assignments and holding office hours, and like working with other people in the department who are professors. And how do you get this? You talk to your department. There should be people in charge of the TAs. And this is kind of the default funding if you don't have any other source of funding when you go into grad school. And they should basically promise some level of funding to you when you get accepted to your grad school. And it's going to be baseline in the form of a TA. If you're a lucky duck, you might get a fellowship. And when you're on a fellowship, it's likely because they want you to do research instead of teaching. And this fellowship is going to be probably in the form of like $30,000, maybe over the course of a couple of years. And this isn't probably something you can really apply for, unfortunately. I think at least at U Chicago, there were some little small scholarships given out, like $2,000 for like a research fund here and there. And then like maybe 1 or 2 people in our whole class got a full fellowship, so they didn't have to teach. So yeah, this is likely a random award, but like keep being awesome. Like don't let that discourage you. At some level, it's just like everybody's so awesome, it's kind of hard to decide who gets these. And lastly, there is fellowships from a government agency, organization, or individual. And I have the expectation of what you should be doing if you're on fellowship as doing research well. So really the expectation is to just do research, like do what you'd usually do. But when you are applying for fellowships, they want to see that you're basically an all-star when it comes to science. So how do you get this? You apply and you're just like, hope for the best. So for the rest of this talk, I'm going to be talking about fellowships because these are the things you can do something about right now. And all of y'all should absolutely apply because you have nothing to lose. Yeah, so going into that a little bit further, but Claire, TAs and RAs already cover my basic expenses. Why should I spend the time to apply for an external fellowship? So put generally, money opens doors. Like money is a good thing. But more specifically, it will be likely that your fellowship will be slightly higher in funding. So for example, the NSF fellowship for me is like $34,000 as opposed to, I believe, 30 or 32,000 is what would have been getting otherwise. You can support yourself and literally do anything you want, which is quite a big one because a lot of people, a lot of advisors may not have the resources to support you. So if you're in love with one particular research group, like you're in. It will give you experience. So generally applying for fellowships will put you in a better position for potentially applying for money in the future. And also it's just like, it helps you communicate science in a different way than you might have thought otherwise. If you're rejected from your dream school, well, not anymore. Um, Places like MIT and Harvard are really competitive, but if you have money and can support yourself, you're in. Like, you can just contact them and be like, hey, I won't be a burden to you. Like, I will be literally bringing good things to you. Um, so this is a huge point of leverage. You don't have to teach if you don't want to. This is pretty nice because as graders it can get a little bit annoying, but like this is just, it just takes off the pressure of teaching. And lastly is swag. This is quite legit. So this is a great resume item to put on your resume. You'll get mild fame after the results come out for if you've won the fellowship or not. Um, and all of these options are like, all of these reasons for why you should apply for an external fellowship are pretty real. So for me personally, I was talking to Jamie a little bit about this earlier. I'm kind of thinking about looking at another field for my future after grad school. And I kind of want experience in that field to see if it's even right for me. So thinking about using my money to kind of take a science vacation, so to speak, where I can work in another group for a little bit, but I won't be a burden to them at all. So it will be more likely for them to say, accept me for a summer while I explore my interests, um, than if I had to be paid by them, for example. Do you guys have any questions? Super duper. So for the remainder of this talk, I'll be talking about fellowships and most specifically the NSF GRFP fellowship, which is a mouthful. And unfortunately, all the fellowships I've seen for physics have been limited to US citizens, but you should still look to see what's out there if you're not a US citizen. There are also fellowships geared for like particular individuals. For example, if you want to become a teacher or are an underrepresented minority, there will be fellowships out there for you. So just going down this list, the top two up here, NSF GRFP and NDSEG are, I think, the most uh, winnable fellowships. They're very kind of like umbrella fellowships that will accept many different kinds of people. So for the NSF GRFP, you'll get $34,000 for 3 years. It's a butt ton of money. You'll officially be on fellowship for 5, but the monetary part only lasts for 3. You can apply as a senior, and then when you're in grad school, you can apply if you're a first or second year. So you can only apply 1 year in grad school, which is why you should absolutely apply now if you're a senior. And the deadline is coming up right around the corner. So, whoo-hoo, good luck, people. Um, NDSEG is a little bit more, 38,400 for 3 years. And you'll also get like a travel, like $5,000 of travel allowance, except instead of being able to apply once in grad school, you can apply twice. So that's pretty nice for that. The deadline is coming up as well. So if you're applying to the NSF, you might as well just apply to NDSEG too. And the remaining 3 I have listed on here are also kind of main fellowships, but they're a little bit more constrained. So the Hertz Fellowship, it's like a ton of money. It's a lot of money, but they are rather selective. I've noticed on their fellowship page, they kind of accept people from like the same set of 8 schools. And to get this fellowship, you have to go through several rounds of in-person interviews where they basically ask you physics questions on the spot and you have to like solve them. So it's a rigorous process, but I know somebody who won this recently at U Chicago, and like, oh man, it must have been a time. That's not to discourage you from applying to Hertz Fellowship, but it is a rather rigorous process. And then there's also the GFSD, which is another wonderful acronym, which I believe they want you to do an internship with them, which if you don't want to do the internship with them, that's maybe kind of a turnoff for applying to that, but it is a good amount of money. And if you like the idea of the internship, then like might as well. And lastly is the Ford Foundation, which kind of targets underrepresented minorities. and is another good chunk of money. And they were very unclear when this was when the deadline was on their website. So apologies for not having that. But if you think you fit into this category, definitely apply for Ford Foundation as well. So if you were to win a fellowship, most of these fellowships will also cover some level of your tuition, if not all of it, which is great for you, great for your advisor, and like great all around. And with that, I'd like to say you should apply to these two fellowships like right now. It's maybe a little bit late in the game if you haven't started because you'll need letters of reference for them. But if you are lined up to apply, you should absolutely apply, even if you think your application is hot garbage, because it'll just be like a great experience and you'll get feedback. All right, so from here on out, we're going to be talking about the NSF GRFP in particular, and that stands for the National Science Foundation Graduate Research Fellowship Program. Wow, that's a lot of words. Are any of you applying to this round around? Jamie is. How many other people we got here?
It looks like in the chat, Rishi is also applying.
Nice. Excellent. Yes. So good. You guys already know. So when should I apply for the NSF? In case I haven't convinced you already, if you're a senior, you should apply. Like this is your freebie chance to apply because once you're a grad student, like you'll be in a pool of more competitive applicants because they kind of expect you to have a higher level of understanding of the research you are going to be doing. And it just maybe is a little bit harder to win. If you're a first year grad student, you should apply if you kind of know what you're going to be doing, even if you like only kind of know what you're going to be doing and you have a PI or a principal investigator, which is another synonym for advisor. If you have a PI, they can really direct you quite well into like the direction you're going to be going long term. And if you're a second year and you didn't apply your first year, you should absolutely apply because that is your last chance. I tried to convince my roommate to do this, but she is not doing it. So really, I strongly encourage to apply, but the decision is ultimately up to you. Your advisor may strongly encourage you to apply as well, because if they get money, that's good for them as well. So the application components for the NSF GRFP are kind of like the standard graduate school application components plus an additional research statement. So you'll have your generic personal information, education and work experience, which is kind of like your resume, but input in a different way on their like official portal online. Electronic transcripts, your proposed graduate information. So like what field do you think you'll be in? Who do you think you'll be working for? Which is kind of hard when you're a senior and you really don't know, but like you just gotta like commit to something and try to convince them that that's what you want to do. That is your recommendation. I think they allow you to submit more than 3, but I don't know if they read more than 3. And then lastly, the written statements are really important. So 1 through 5 here, you can't really do much about when at the time you're applying, but 6 is like your time to shine in your written statement. This is where you can like knock it out of the park and set yourself apart from the crowd. So that's why I'm going to talk about the written statements. So there are 2 main written statements for the NSF GRFP. There's the personal relevant background and future goals statement, which is 3 pages. And then there's the graduate research plan statement, which is 2 pages. And we'll talk about kind of like what the structure kind of should be for both of these in the coming slides. But before I do that, I really want to emphasize a couple things. Firstly, is this is ripped right off from the NSF website. They really freaking care about formatting. If you do not format exactly the way they want you to, you will be disqualified. And I know people who have been disqualified because they didn't have the right size margin or something. It is very stringent. So I kind of recommend people to use Word instead of LaTeX in general, because LaTeX, there is a possibility that like the formatting, you might think the formatting's correct, but like maybe it's not. Um, but if you like double check and double check that LaTeX is okay, then like, okay, use LaTeX. Um, and secondly, um, they care a lot about intellectual merit and broader impact. So if you're writing these statements, you should mention these two sets of words by name in your statement, like put them in bold or something, because when they review your statement, it will be they will be reviewing what's the content of your statement um, in light of these two categories. So I'll show you a little bit later on, but oh, it looks like there's something in the chat. Ah, yes, good. That's really good. A template with the requirements. Thank you, Jamie. Um, and then lastly, what you can think about for these statements is like, I want you to go in writing these statements or editing these statements, thinking about this kind of like a psychological game. Like, who is your reader going to be, and in what position are they going to be in when they're reading this? Your reader is likely to be either an expert in your field or a non-expert in your field. That's kind of the only two things that you have there. So if you're using jargon in your, say, research statement, you either want to explain it or not use jargon, but I think using jargon and explaining it looks a lot better. You want to look like you know what you're talking about. And then secondly, a lot of the readers are probably skimming many other statements. So it's okay to repeat things and really like bash your reader over the head with like important concepts. Yeah, like they may even be reading this at like 1 a.m. with like a crying child in the background and like they don't have their coffee. So expect that your reader, for example, may be grumpy. And in that sense, it kind of is the result of if you win NSF or not can be dependent on who reads it, which is kind of not the best, but is kind of the reality of things. All right, so let us continue. Structure. Let's talk about the structure of the personal relevant background and future goals statement. So I kind of have a, if you were to imagine your statement laid out, it would look something like this with appropriate lengths sized to the boxes. So you should probably have a catchy opening. So something that will immediately set you out apart from the crowd, and not have it be very long, because in this statement, you want to be focused on what skills you have and have learned, as opposed to like, oh, I like this and that, and like everything is wonderful. Like they want to see that you are a qualified applicant for doing research. So for example, catchy opening, my first inspiration to study physics was in the form of a sandwich. Like that's weird. That's like good weird. If your voice cuts through your statement, it's probably more likely to be memorable. People might see in my statements, since I sent a link to Jamie to send to all of y'all if you want to see them. I think my first line was physics keeps me awake at night. And then I talk about like destroyed integrals and other stuff like that. But yeah, catchy opening. It can be a little personalized, but like you want to start focusing on skills right off the bat. So which is why I lead to research experiences. So for example, you would frame each research experience in the sense of like, I did research in this field with blank at like Fermilab. My goal was to measure neutrinos, and I learned how to do Python analysis. And the conclusion of my research was like, we measured the spectrum of the neutrinos, and it's going to be useful for future scientists. Kind of like your whole experience wrapped up with a little bow about like everything that you've learned, maybe even showing that you worked in a team and you worked in a team effectively, not just that you worked in a team. So all the research experiences you've ever had, you can put into your into this statement. And then you should also talk about your leadership, teaching, and outreach experiences. Now, this basically falls under broader impacts. So for example, you could say you were a board member on SWIP, and then you helped develop the skills of females in physics. Having outreach in particular to underrepresented minorities is very important for this kind of statement, or like just diversifying your field in general. There's also things like I engaged the public in science at engineering open house. Engaging public in anything is very good. Or for example, you're a good teacher. Showing that you can communicate science well is important to the NSF. And then lastly, this is something you essentially like have to have, but is not necessarily stated anywhere in the NSF guidelines. But you should have a plan for what you're going to do for outreach when you're in graduate school. So for example, at University Blank, I will continue my work in outreach by setting up pizza talks with professors and roping in undergrads to help them get experience with research or something. But like, you need to talk about how you will offer something unique that will broadly impact your surroundings in the future. And then a summary. So I've learned all these skills from research experience, leadership, teaching, and outreach. And this is very crucial. You need to tell the NSF why their fellowship would help you. That's like a must do. And there's like a pretty standard line in how you would maybe say this. Like, the NSF would help me by furthering my opportunities and like give me the time to do blank. But to some level, that's like true. So however you think the NSF would help you, you should say it in a sentence. Any questions about the statement? Cool. Next is the graduate research plan statement. So this one is probably the most intimidating. And the first time I ever wrote one, it was really quite trash. So hopefully I can drop some knowledge on what I've learned since then. So this is kind of like another general structure of what it might look like. Yours may look different. And just as a side note, like, it's okay if your statements don't look exactly like this. This is just kind of a cookie cutter structure of what I think a statement would look like. So anyway, you want to start right off the bat with a broad motivation for your research. So for example, neutrinos can help us innovate and understand the universe. We can use them to communicate between submarines and like detect nuclear activity from other countries. And then from there, you want to kind of narrow down the scope to what you will be doing in particular and how your particular research helps contribute to the broader picture. And that will lead right into what your research proposition will be. And this is going to be a very short, maybe like 1 to 3 sentences about what you're going to be doing for research in grad school. So I will develop the first model to do blank and test it by blank, and any other relevant details you think would be important to your particular research. So this research proposition should be something that is like a multi-year project, because NSF will not want to fund something that's going to take like 6 months, for example. They're looking to fund people who will take a full PhD or close to that. Yes. So after you mention your research proposition, you kind of want to take that and go way into detail into it. So next is a step-by-step plan for conducting research, the exposition of your research, or like explaining kind of like more background, what tools you have available to you and how you're going to measure the success of your research. So for example, CERN's data collection consists of blank, blankety blank blank blank. It contains FPGAs. I will do machine learning on an FPGA to do blank, and we'll test it on blank to measure its efficiency. So this is like a very, take that paragraph and make it into like 3 paragraphs, and that's going to be a big chunk of your graduate research plan statement. Um, Another great thing to include in this statement is to mention challenges and how you're going to overcome them. That kind of elevates your statement to the next level. That says, oh, this person understands beyond more than just how it works, but like how it doesn't work and how to correct that. So yeah, one of the challenges in biophysics is blank. I will overcome it by doing blank. Um, and then from there, you can kind of wrap up everything that you've talked about into a short little paragraph. My research will allow for blank, which is maybe like some broadly applicable, useful thing. And I have the tools necessary for success, which might be like your advisor's lab, like a computing cluster or something like that. And an NSF fellowship will help me further by doing blank. That's another crucial line to have in the statement, is how NSF is going to help you. And then in this statement, you absolutely should have references to back yourself up. Otherwise, it's going to look like you're just saying statements without any sort of viable underlying knowledge. Yes. Any questions about this? If you use jargon, don't use jargon, or explain the jargon.
How many references would you recommend us having?
I would recommend between maybe 3 and like 7. It's pretty variable. Like I think 4 to 5 is maybe a sweet spot. You can also, I believe, put references in smaller font. Yeah. If you need more space, it's possible that like cutting out one reference would be okay. Yes. So yeah, I'm reading my notes to myself. So by the time you're done writing the statement, you should ask yourself, does this proposed research sound like it's going to take a full PhD to complete? And if not, you need to just make it more beefy with details and like even talk about how long you think something will take. Like it will take 2 years to accomplish this, in which case I will continue on to this part, which will take another 1.5 years or something. Yeah, and another thing that it looks great for these statements is completely filling the pages that you have to work with. If it looks kind of like bare bones, it looks like you maybe don't have all the details down. Like make it look like you literally cannot say enough about what you're talking about. Alrighty, so anyone who applies will get awesome reviewer comments. So you actually learn quite a lot from these. This is an example from the NSF application that I won. So they will literally bunch feedback under intellectual merit and broader impacts. And this is just like one of the reviewers' comments. So they said I was excellent. Wow. And then this other person said I was very good. In the application that I didn't win, these both said like good. And you might see that in the folder link I sent y'all, or I sent Jamie, but hopefully she will send on to you. So for example, they'll go into like what they thought was good. You received an award. And then I believe there's maybe, yes, there's ways, they're in your feedback, you can figure out ways you can improve your application for next time. So for example, the applicant would improve the research statement by explaining the potential impact of the proposed work on a broader audience. So say, for example, as a senior, you get this kind of feedback back. You kind of know what you need to change for next time. All right. Any questions here? Because we're almost done with the presentation. Okay. Lastly, if you actually win, you will get these 3 things basically right off the bat. fame, mild fame. Your face you'll find your face on various like things that you didn't even know you were on. Like you'll just be walking around and they'll be like, congratulations, so and so, and I'll be like, oh, thanks. Like that's cool. Um, you'll need to complete an annual report on the NSF website. So this is just to make sure you're like you didn't like drop out or like uh aren't goofing around, and that you're still doing some level of outreach on a year-to-year basis. But basically, once you get the award, you have it for the whole time. Um, and then lastly, you'll get a check in your bank account for $8,500 every quarter, and that's a very nice feeling, getting a chunk of money. So at this point, I'd like to ask if there are any questions. And I don't want to limit it just to fellowship and funding, but like if you are wondering if grad school is even right for you or anything else about grad school, feel free to shoot them off or email me. My email is the Baum at uchicago.edu. And then this is the link to my statements that both won and lost and the reviewer comments for them. So you can either snap and fic, or Jamie will send this out and I'll probably send this presentation to her so she can pass it on.
Yeah, I'll be dropping the links in the chat, and I'll also be hopefully uploading that to the website too, so you can grab them there.
Great.
I would also like to point out this deadline here, October 22nd, is for the physics NSF.
Yeah.
The engineering one is earlier. So if you're planning to apply for engineering NSF fellowship, then the deadline's just a bit earlier.
Yeah, good point.